Hello everyone, welcome to this stream. Today we will work on continuing assembling the Pmods for game controllers. So maybe if you saw the previous episodes, you saw I worked on the Pmod for the icebreaker, which is this board. Let's see. So this is the Pmod itself. And the point is to connect gamepads from old 8-bit consoles. Let me pull them out. Why didn't I pull them out earlier? So we want to be able to make retro-inspired game consoles with the icebreaker, or implement emulation for NES, SNES, or even for other FPGA dev boards like the ULX. You want to be able to use gamepads like this. So I got the gamepads of two different generations here. So SNES and NES. And I made boards for this that we can use. So this board implements the level shifting for the gamepads, as well as a circuit for audio, which uses PDM output. Which is essentially digital to analog using just pulses. So it's an interesting solution that we worked on. So this is what we will assemble today. And I also got the pods. So I wanted that I didn't want to just commit to one type of connector for the gamepads. So instead of putting the for example, these are SNES connectors. Instead of putting these directly on the Pmod, I decided to put them in pods. This will allow us to put the icebreaker, for example, in an enclosure, and put this on like a front or a top of the enclosure and connect to it. So that's the idea. And there is a second pod currently which uses the Molex SL connectors, because I ended up for other project cutting off connectors, and these are nice retaining connectors that take up less space, so we can use these. So these boards are from Oshpark. The purple one is the standard 4-layer Oshpark color. The substrate is white, so it makes it very nice and vibrant, because it is FR408, which is the material used for the substrate used for the purple boards. And these are so-called After Dark. These are 2-layer PCBs where this is copper. So it has black substrate, which is the material that it is on is black. And then it has copper on it and clear solder mask. So you get this really interesting color combination. So if the copper is covered with solder mask, it becomes this like flashy pink color, and otherwise it is very pretty. So yeah, it's black FR4. So so this is After Dark Oshpark. And the difference from this and any other manufacturer is these are actually high TG. So high TG, what this means, it's glass transition temperature. So essentially when the material gets soft and starts warping, usually the black substrate has a very low TG. So it starts warping and changing form at much lower temperatures than you need for normal reflow, really. It does work for leaded solder, but for lead-free, it is too high of a temperature. And this is clear mask on FR408. Blizzard. Oh my god, this will be great. Yeah, this will be very white. Oh man. Drew, that's awesome. So PDP7 is Drew. He works for Oshpark. So so yeah, that's awesome. That will be really beautiful. So yeah, anyways, so these are the boards. these are the connectors for the... I unfortunately, turns out I only have 10 of these connectors. So it is only for 2.5 of the pods. So yeah, I need to order more. They take a while to get here from China, unfortunately. Oh, and one more thing. I finally got the NES connector. So this is NES, so Nintendo Entertainment System. And this is Super NES, so Super Nintendo. I want to make a pod for that, but the problem is I could not find any drawings, mechanical drawings of this connector anywhere. So I had to wait and order these connectors and wait to get them. So I will have to draw my own mechanical drawing of these, and then I will be able to put together a pod for this. So that will be interesting. DVD Freitag, welcome. Oh, Twitch Prime, thank you so much. I really appreciate it. Like, the support is really appreciated. That really helps. All right, so we have a stencil. So we will be assembling them with reflow. So this is a stencil, a metal stencil. This is from Osh Stencils. Do yourself a favor and order from Osh Stencils. Don't buy the cheaper ones from China. They work, but they are annoying. It's like I gave up. I'm too lazy for this. I stopped buying the Chinese stencils because yeah, they are cheap, but they cause me too many headaches. Especially they love to mess around with the Gerber files, and it happened a few times where they screwed up the stencil because of it, and then I have to reorder, and it takes another time. Don't have time for this. So Osh Stencils is my choice. Oh, it glows in UV. Yeah. The substrate glows in UV. I don't have a UV lamp. I need a UV torch. I need to get one of those. Oh god, 250 badges in a night. Oh man, yeah, I can imagine this being fun. Okie doke. So I already set up, so these brackets, you get them as part of the Osh stencil. When you order them, you can add this laser cut bracket. So these are the brackets, and then I have a spare board. It's a Blackmagic Pro PCB prototype to keep it in place. Then I adjust it. I use my watchmaker's loop. I didn't even realize this is something I brought from Poland, from my dad's. It's my dad's loop, so it is a nostalgic item for me. And it says on the back, I didn't even realize, it says Polskie Zakłady Optyczne, made in Poland, Warszawa. So it is PZO. PZO. It was made during this still in socialism, so this is really cool. And this loop is really high quality compared. I got another one like from Amazon. Man, that thing is crap. It has so much like optical aberration and distortion. It's really annoying. And this one is very smooth and works really well. So yeah. There you go. So that's a little bit historical item in there. Anyway, so I use the loop then to adjust and make sure that it is in the right spot. How many components? Let's see. Oh yeah, so for the components, so let's switch to the desktop here. So this is the keycut design. So this is the board. And what we will use is this tool, which is the interactive HTML BOM. And actually, we don't need this in this case. Well, we can generate the BOM. And then it pops up, and we get this. And yeah, I did source these 10K resistors. I think I have those. I should have checked more. Anyway, so this is HTML BOM. You can see one of the cool new features is that you get actually also traces now. So you get nets, so you can inspect. This is really good for debugging. Just like inspect AR is, if the board is in their database, or you have the pro license to add it. Inspect AR is very nice. But if you don't, then this is close second for sure, where you can get the nets and actually see what traces are. And also you can click on the trace and then see, oh, that's the signal. And then this one, oh, this is the signal. It's really cool. I really like it. I'm looking forward to also having schematic in here. So I think that I would assume they will add also schematic view in here. Eventually, so you can also get it in single component list. So if you ask how many placements, it's 34 placements, including the through-hole ones. But if we remove the through-hole ones, I guess it is like 30-ish. It's not that much. It's not a feature in KiCad, it's a plugin. You just download it and install it. Let's see, there should be a link to the... oh, so by the way, I did create... So this is the HTML BOM. So this is, you just clone this directory into the plugins directory for KiCad, and then KiCad should detect it. I heard some people had issues on Windows with the plugin directory not being detected right. I don't know the details. I rarely use Windows, so it's hard for me to confirm or refute. It works magically on Linux. It's like you just clone it in there and you're done. And git pull and you can update the plugin, which is really nice. So yeah, HTML BOM. So I also, in the doobly-doo down there, and there's a link to my streaming setup, and I keep adding stuff to it. Let's see. Keep adding features. So what was I saying? Oh, I keep adding stuff that is in there. So there is a gist. This is the wrong gist, I'm sure. So there's a... There we go. So that's the gist. And I have my streaming setup described here, and also a bunch of the software is in here. I think the KiCad plugin is not in here. So if something is missing, like the HTML BOM plugin, let me know, or create a pull request if you can. So I think this should be possible to add pull requests on gists. So just let me know what is missing. I try to keep a running list of the software using on the streams. So yeah, there we go. And DVD Freitag, he would like you to see the badge. So let's see the badge. Yeah, there we go. That's proper floppy disk. It's the save icon. I heard this is the save icon. Why did you make a PCB in the form of a save icon? Oh man, I'm old. Fits in a floppy drive as well. Can you know what would be really cool actually is to make a fake floppy disk that actually the cassette tapes, you know, that you use to connect your iPod to the car that has a cassette tape deck. Making a disc like that would be really cool. Oh man, so cool. But I will reprimand you for the use of the tag connect. You are forcing people to pay $60 for a cable. Don't do that. Yeah, so apropos, I did get the what are they called? free connects or something. So there is a project on group gets that I got. Group gets and Pure Connect, there we go. So if you want to save money and connect to this connector, I hope that they will do another round of these. So I will probably try to assemble this, one of them at some point, and then show you at least an assembled one. So yeah. Anyways, it's an interesting cable, but I think it is overpriced. It's very expensive. It's like, so yeah, that's why I'm not a huge fan. All right, so let's get back to it. I'm getting on all the tangents today, so let's see. So solder paste, let's do that. And let's switch to the desktop. Oh yeah, it's fine. That's why it is a stream. I could be also more disciplined, you know. It's but I enjoy it. I think it is the distractions are part of the experience of streams, and then we get into interesting conversations. I can rant a little bit, complain a little bit, maybe be happy about something a little bit. In general, I'm trying to be positive as much as I can. It's not always easy. All right, anyways, so I need to spade out. So first of all, let's mix the solder paste a little bit. There we go. To even out the so my solution for a pogo pin interface on PCBs is the one I have on the Blackmagic probes. Let me show you quick. Where is it? There. So let me show you really quick. I'm sorry, slightly tangent here. So what I did is have a pin header here, a 0.05 millimeter pitch. I mean 1.27 millimeter pitch connector header, which you can still solder in and use for development and debugging. But I also made myself, this took me like an hour, a pogo pin adapter, and it has a marker for polarity, and it's pretty easy, and you just poke it in there, and the pogo pins are bigger than the holes. So it just bounces in there, and then you can program it. That's how I program my Blackmagic probes. It's really easy, doesn't require an additional connector, and it takes less space than the Tag Connect because it doesn't have all the mechanical retainers and blah 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 blah. So it is really takes very little of the real estate on the PCB. So yeah, that's my solution. Soybyte. Oh yeah, I think I heard about this. Yeah, that's a great solution too. I should try that out. This is wonderful. These SOIC adapters. Oh, let me show you the desktop. Man, this stream is going on tangents all the time. So yeah, these. Yeah, I did see that. I have to try it out. This looks very good, actually. So, being on the edge of the board, and these clumps from AliExpress are dirt cheap. So you can just give it out in a class too for workshops. So that's really nice. Yeah, so yeah, I need to get some of those clamps. I think I nicked one from Joe Fitz in the past. I should look if I have it still. He uses for his workshops, for his classes. He uses the SOIC clamp for programming of the at Megas. So yeah. But yeah, they are very, very cheap, fortunately. They're crap. They break, but it's like because they are cheap, you can replace them really quickly. So there's always a balance between cheap and expensive, you know. All right, so yeah, without the plastic hooks, yeah. Yeah, I think the clamp might work with the SOIC one. I did program like hundreds of Blackmagic probes with my pogo pin adapter. And it's like, yeah, yeah, you have to press it, but it's if the programming is fast. Okay, spatulas. There we go. Putting paste on the mask. Sorry. So yeah. Let's do this. Let's do another one. Wow, I put my hand in there. Great. Trying to do it under camera so that you see what I'm doing. And then I'm making a mess of it. Okay, so what I use are these wipes. I love these wipes. They're called Stencil Wipes from Tech Spray. They have a number, and the number is 1608-100FL. That's the nice thing about Tech Spray. They have IDs for all their products, so you can exactly say what you want. So yeah, can wipe this. I don't need this. Can close the jar. Close the jar. I should have zoomed out earlier. And then we can work the paste to distribute it on the spatula nicely. So some people put it on the stencil and then wipe it off, but I prefer putting it on the spreader directly. So yeah, there we go. And then like this, and then slowly take your time. One wipe, not more, not less. One wipe. I've seen people just go ham. Like I'm repeating myself. I already said that in the previous assembly stream. But yeah, some people just go like swipe, 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 swipe to press it in, and it's like you're making a mess of it. It's just squeeze everything under the stencil. What are you doing? So yeah, one wipe, move it, remove it, and then we have this solder paste on the board, like this. Come on. Focus, 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 focus. Yep, I will adjust it in a second. So that's that. Let's do another one. Yeah, I usually assemble more than one board. So let me do this and then focus. There we go. And what I do also is take the IPA soaked wipe and then go in the back and wipe it really gently. What it does is remove the excess. It's usually not the solder balls themselves that start accumulating. If you do it multiple times, it starts doing that. But the main thing is there's flux that is being squeezed under the stencil, and it's starting to make a mess and starting to elevate the stencil from the board. And then the balls start going in, and it becomes worse and worse and worse. So if you just wipe it from the back between every second stencil application, you keep the quality of the dispense better. So wipe it from the back, wipe, 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 put it down. And yeah, I can remove the excess solder paste here, and then just do this, and then distribute, and then distribute. Trying to see if I can get it on camera like this. So I have a nice bead on here, and then we should probably put a PCB in here. So we put a PCB in here. Click, click. In there. You can even inspect if it is still aligned, because it likes to wander around, because the PCBs are not always perfectly produced. It's not always Boschpark that I assemble. Boschpark is perfect. No, it's not, but it's they're good. So yeah, and then down and a slow swipe. One swipe, not more, not less, one swipe. And then pull it up, remove, and let's check it. Let's check a different section this time. There you go. Let's try to make a... There we go. And then we have solder paste on the pads. It's completely within tolerance. We get nice definition of it. It really depends on the solder paste. I learned if you get the crisp edges or not. So my solder paste, like a bucket like this, is usable for about a year. Then it is only like very coarse PCBs can be assembled with it, because the flux is not good anymore, or it is too dry. It's like evaporated too much. You can still rejuvenate it a little bit by adding some IPA to it, like a 99% IPA, but I wouldn't use it for fine featured boards, only for coarse stuff. So I have several old containers that are not fully used up because of it. That's the reality of it, unfortunately. I do not produce still enough to use up a full container in a year, unfortunately. So yeah, and then the third one. So let's assemble all three. In, close, and dispense. Take your time, and done. All right. That makes us happy, right? There we go. Wow, did I just wipe it off? Great, well done. I think we can still rescue this. I don't have to wipe it off yet. I think this is on a very big pad, so it shouldn't be a problem. So let me put this solder paste back into the bucket. This is what happens when you do it on stream. Everything goes wrong. Portland Murder, welcome to the stream. Yeah, there are several people that I forgot to mention. Agent Denton, I think, thank you for the follow. Maxi Alpha, Pizza, thank you for your follow. IPv1, thank you for the follow. Welcome to the stream, everyone. It's not a live demo if it doesn't go wrong. Yeah. So yeah, I use knocking to put the stuff into the bucket. Sorry if the lapel microphone is picking up some noise. There's a construction site outside and they are being very obnoxiously loud. But I hope the lapel microphone is rejecting most of the noise So yeah, there we go. Use this, and then we can knock it down. So you see there is the bead, and then we knock it down to decrease the surface area, and then it sits in there, and we're good. We can close this, close the second seal. Come on, come on, second seal. Second seal. And lock it. Done. All right, now we can wipe this. Wipe this. Wipe this. Clean, clean. Cleanliness is paradigm, right? There we go. All right. Let's see if we can rescue this other board. So let's go under the microscope, take some tweezers and readjust the solder paste on here. So these ones are fine. Let me move the keyboard out of the way. There we go. Oi, oi, oi. Peter made a mess. There we go. Shouldn't be a problem though. This is a big component, so there we go. Yeah, we can steal some from here. I need some other tool to swipe it off my tweezers. For example, a pin. Is it dirty? It's dirty. There we go. That should be good enough. It's not a big problem. There will be some balls here, but not a big deal. Can always come with a soldering iron here and fix it. All right, so I still need to. I threw it away, but I shouldn't have. There we go. All right, so let's start. Let's zoom out. We don't need that much of zoom. And then I get my box with my basic components. And then we have to go here and start with the first component, which is the 100 nano decoupling capacitors. And I did refill that box yesterday, so we should have enough of them. There's a lot of them on this board. I'm pulling them out with my finger. Maybe we can zoom in here. Not sure this is actually useful. There we go. But yeah, this is in the way. Let's move it, move it, move it. All right. So I usually do this like that, and I have 3 boards, and then I can move them all 3 together. So that makes it. It is an Oshpark PCB. It's nice and purple and very flat. Silkscreen. Yeah, that's the word. All right. So what do we need? Every of the top ones. So these are the top ones. This one, this one, this one, and then these all are 100 nano. So let's do that. I should probably have them rotated like this. That should make my life easier. Is that in the center? Let's do this. Yeah, there we go. Focus better for myself without breaking it for you. No, that's fine. So these are level shifters. So there is the decoupling capacitor on the input voltage and the output voltage. That's why there are so many decoupling capacitors. I know they are not strictly necessary to have that many, but this better safe than sorry, I guess. No, this is all 402s. These are all 402s. Okay, so that's that. Then what else? We need two here on the top. So this is supply for the audio, for the left and right channel. So this is the filter circuitry essentially that uses buffer and inverter to get a very sharp second order filter for the audio output that is being fed in PDM. And then second board. Yeah, so what already helps is getting one of those cheap camera microscopes. So several people I know just got camera microscopes to get some like visual augmentation, and that helps with everything. Even if you, it's like I'm even solder like pin headers under the microscope because I find it easier on my eyes and on me. So having a microscope in general is a good idea. It's a good investment if you are into the Yeah, thanks DVD Freitag. Yeah, that's correct, Jiggly Girls. Just there are several ways of doing this. You can for prototyping you could use a rework heat gun. You could use a hot plate or a skillet, electric skillet, or a reflow oven. That's my weapon of choice. The hot plate is mostly useful for really large components that you need to rework. That's what I use it mainly for. But it is a cheap solution, fairly cheap solution. Cheaper than a decent oven. But I have one of those Chinese, or actually two of the Chinese reflow ovens. If you look in the instructions or the list of what I use for the streams, there's a link. There's the name of it, as well as a link to my blog where I describe the modifications I made to mine. They are very good things to do. You have to pretty much do them to your oven if you get one of the Chinese ones, but you get a very decent oven this way that is actually meant for the purpose. Welcome to the stream, whatever your name is. What is your name? Cobra Pine, welcome to the stream. Thank you so much. And the follow. There we go, and a few more. So these are just the decoupling capacitors. I think I could have, I usually put one decoupling capacitor per power rail of each chip, but I think in the case of those level shifters I could cut it down by a fair amount and still be good. So you see on the side here, it's like this is how I mark my parts. So you see this is a circle, or here is a circle. These are capacitors. There is a bar here, a continuous bar. These are resistors. And there's this squiggly line. These are inductors or ferrite beads. So that's how I mark my footprints to make it easier on me and not occupy additional space on the PCB without having the markers outside of the board. It's like, so in this case I have plenty of space. I could have the markers, but I usually try to compress my boards as much as I can to save space and make the PCBs cheaper and also fit more stuff in my backpack. So so I don't tend to put any additional markers outside, or yeah, I usually run out of the space on the PCB before I have a chance of putting silkscreen on there. There we go. So that's the decoupling capacitors. That's done. Then next step. Next step is the 10 microfarad decoupling capacitors for the power rails. So we have two rails. One is 3.3 volt and one is 5 volt. And I have 10 microfarad capacitors there. And they are 0603. Now you will see the difference in size. Yeah, so the footprints are part of the pretty KiCad libs library that I maintain for myself. You will find it on my GitHub. Pretty KiCad libs. As in libraries. So these are the 10 micro. And more 10 micros. So the stuff that I'm doing here, so I have so much capacitance on this board, so to a degree I'm concerned that I'm exceeding the spec of USB of the capacitance. I think it is, I don't know, 100 microfarad maximum or something. So yeah, so these are 0603s compared to the, see the difference? So 0402 is essentially as long as the 0603 is wide. So that's usually the steps that they take. And the aspect ratio is the same. 10 microfarad. Which side of your regulators is the capacitance? So one of them is behind, the other one is before. So yeah, I am exceeding the spec. It's fine. It will deal with it. I like knowing how USB devices violate the USB spec all the time. I'm not too concerned. Yeah, the output, yeah, because the output, so first of all, welcome, Sherbrain, or Jared, nice to see you here. And yeah, behind the regulator, because the regulator will actually limit if it is being overpowered usually, if you have a good regulator. Convention on which sides of your footprints gets square versus circle? Which sides? What do you mean? They are between the pads. They are between the pads of the footprint. Yeah, I'm not sure I understand your question. No, I don't have a poly. Is that PTC? Is that polyfuse, I guess? Oh, pin 1 markings? Oh. Well, resistors don't have pin 1 markings. Capacitors don't have pin 1 markings. Oh, you mean circles? Wait a second. Ah, the resettable fuse? No, I do not have a fuse on the icebreaker. I'm sorry. I skimped on that. Yeah, I use the KiCad convention with the like bars where you have the longer bar for the pin 1. So you see here. So there's it's not a great convention, to be honest, but yeah, it's the longer extension of this silk screen here is the pin 1 on these chips. Same here. You have short, 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 long. So this is pin 1. So that's I use the KiCad standard for this. For the pin 1s. For the resistors and capacitors, I don't exactly. Oh, for I think capacitors now the convention is for polarity to put a close this up, this silk screen around the pad. That's not a bad model. Oh, I'm sorry, I meant to show you here. So basically, if this would be pin 1 or the minus side, right? So you would have the this closed off. I don't have that at the moment. I rarely use polarized capacitors, so yeah, there we go. Okay, so 10 micros. And now we do the 4 and 7s, which are... Do we have anything else I can pull out of the box here? There were 10... the 10... Yeah, the 10 kilo ohms. So let's mark these. So I can 100 nanos are placed, the 10 micros are placed. 4 and 7s in 1206, these are for the audio filter circuitry. Then 100 microfarad, it's also the output for the audio. Then we have 1 kilo ohm. I will use the 1%ers for this because it's also filter circuitry. And then 10 kilo ohms are just pull-ups and pull-downs for the level shifters, so we will place these. 10 kilo, correct? Yes. So how many do we need per board? We need 3 per board. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Wow, too many. Whatever. We'll put the rest back in the box when we are done. So these are the pull-ups and pull-downs. Oh, I see. There is some text here that spilled over that I forgot to remove. Well done. I see you. There we go. 10 kilo. So the pull-ups and pull-downs basically set the direction of the level shifter, if it is an input or output. I said that before in the previous stream, but I do not like using the automatically changing direction level shifters. They and I'm not talking about I2C because I2C is specific and weird and I avoid it in general. But for other signals, using the automatic direction detecting ones is just asking for trouble, unless you control both sides of the circuit and really know what you're doing and you test the crap out of it. I had, yeah, this is, they are dangerous. Don't use them if you can avoid them. Use settable direction, bidirectional level shifters instead. I know it takes an additional pin and it can be a pain in the butt to find that pin, but you will have a much more reliable system this way. And especially in this case, all the pins have set directions, so there's not a problem. Yeah, pretty much anyone I know that tried using the auto direction changing level shifters, they all will agree with me that they are problematic and cause problems. So just don't use them unless you really have to, or have full 100% control of both sides of the circuit, and you can test it and make sure that it will always work. All right, and the last one. Okie dokes. 10 kilo ohms. This one is one extra. I like SPI. I don't have a problem with SPI. I have a problem with I2C. We don't like each other. It's a mutual thing. Yeah. So I2C again, if it is on the same board and you have full control over the system and all the components in it, you can use it. Glasgow uses I2C for the internal configuration, like the level shift, the DAC, ADC, and the GPIO expanders for pull-ups and pull-downs are on I2C. But that's fine because it's all on one board and used as it is intended to. I2C is meant to stay on the PCB you are on. It's not meant to go anywhere else. That's what it was designed for. But I2C is a pain in the butt to implement right. The peripherals, like Atmel got it very well, but they are an exception. ST, I2C, the IP used in STM32s that ST has is really painful to get reliable, to work reliable. It will work somewhat, but if you have any like signal integrity issues, it will just cause you a lot of headaches. So if you can, use SPI or use some differential signaling stuff like CAN, or run something different over CAN, or use RS485 or something like that. Interconnect between stereo system components at some point? Yeah. Sure. It's a horrible idea, but I guess. Try the ICE40, I2C core if you want pain. Yes, thanks, Sylvain. I2S is different. I2S is a clocked interface and it's unidirectional. Don't confuse the two. Yeah. So I2C is one thing. I2S is an audio interface protocol, and yeah, I don't have enough experience with I2S, but as far as I can tell, it's a clocked interface with one direction. It's more like SPI. Yes, it is more SPI than it is I2C. So yeah, I think it is as far as I know, it's fine. Oh, within. Oh yeah. So there you go. So yeah, DVD Freitag confirms it's pretty much like it's a riff on SPI. It's full of surprises. Oof. Full of surprises. That's the best thing in engineering. It's like if you work on something that is full of surprises, that's pain. Good pain. When you get it to work, I guess it's fine. Geek Lord, welcome to the stream. Thank you for the follow. Randrikus, thank you for the follow. Welcome. Yes, KeyCard HTML BOM. Yes, that's the software in the corner, and that's a plugin for KeyCAD. What's next? So let's mark this off. So the 10 kilo is done. So I can now, oh yeah, I can do the ferrite beads. We have ferrite beads here. They are also 402s. And we need 1, 2, 3, 4. Come on. 4, 5, 6. It's too many now. Too many of you. There we go. 1, 2, 3, 4, 5, 6. Perfect. So this is the power supply for the buffer inverter pair for the audio channels to implement the second order filter for the PDM audio input. So we are not using I2S or anything. It is basically just PDM audio coming out of the Icebreaker FPGA board. And then this filter filters out the high frequency components. And then we have a RC filter in the back to get a low pass filter. And then we couple it, AC couple it to the audio jack using the 100 microfarad capacitors. I'm really curious how well that audio will work. So in preparation for that, I got a USB audio capture interface and stereo audio capture interface. So currently I'm using one of those cheapo USB from Siba, the audio interface boards, but it's only mono and meant for microphones. So I got one for transcoding your analog cassette tapes. That's what they're selling it as on Amazon. And it's like an USB stereo audio interface input with a 3.5 millimeter jack and 2 chinch. What are they called? The coax things. I only know the German term for it. They're called chinch. Chinchstecker. Klinke. RCA. Yes, that's the term. Thank you. RCA. They were big at some point, weren't they? Jukebacks, thank you for the follow. Welcome to the stream. All right, so I think we can now pull out. We still have some parts in here, but let's pull out the unique parts. Where do I have them? Oh, I have Old Man Sounds here. So yeah, there we go. So I did get also foil capacitors, but I'm not sure I want to use them yet. I want to compare them later. Yeah. And especially if you work with retro stuff, they're useful to have. Buffer inverter, so that's useful. Then we have the audio jacks, that's for later. We have 4 and 7, so 4,700 picofarads. So these are these. And then we have 100 microfarad ceramics, 1 kilo ohm resistor, somebody to choose from. I didn't use the Radio Corporation of America inside turntables back in the day, called phono connectors in the UK. 1/4 inch jack. Oh god, that's a collision there. Oh man. Thanks the orb too, that's a good story. Yeah, if you want good, like a bunch of good like technological stories, I find Technology Connections. His channel is really good for weird stories about technology. I really enjoy that channel. Yeah, I did get 4.7 nanofarad 0402 ceramics, but we are not using them today. We will just go with the with the chunkers in the 1206 package. That's 1206 for you. It's huge. You can make a necklace out of them. It's a clunker. Pendant. All right, so let's. We need 4 per board, I think. No, these are the 100 nano. Come on, there we go. These 4. Need 4 per board. Oh my goodness! Come on. There's 1, 2, come on, and 3. There we go. So these are interesting. They are fairly flat, actually, if you think about it. So this is how thin they are. They're just very wide. That's very interesting. So yeah. One, 2. So yeah, I probably should just switch to 0402s for these. I don't think, unless there's some other specs like voltage related capacitance loss and stuff that we need to pay attention to and need to use bigger versions, physically bigger versions of them. But this is something that needs some additional research to see how the audio looks like. I need a spectrum analyzer. That's what I need. Or like a network analyzer or something. That would be really nice to actually investigate things like these. Tools 1. This is content for Tools R Us channel on our Discord. So Vamke wrote a very nice topic for it. It's like the tools we would wish we could afford. I like that. Yeah, that's very, very real. But yeah, spectrum analyzers and network analyzers are not cheap. At least something used good, I mean. But yeah, I should get something from eBay, something used from HP or something. But then it is such a chunker also on my desktop, and I don't really have space for it. So it's all very hard. Oh, the hardship, you know? Oh, the hardship. There we go. Oh, look, Mom No Computer. Yeah, I love his channel. Yeah, I love this. Is such a good channel. Look, Mom No Computer. He's awesome. Also, I'm just always so impressed that he makes it look so easy to take a device that just makes like harsh noises and make it into pleasant music. It's just, how the hell is he just doing this? It seems to come very easy. I'm sure he's working hard on this, but I'm always impressed. It's like, oh, I have this like super noisy noisemaker, and then it sounds great. It's just amazing. It's a good channel. USB input with software. Where were we? VNA, Nano VNA. Yeah, I have to look into the like desktop USB related stuff. Maybe there is something that would be a good stopgap measure. Yeah, let's do 100 microfarads. So we can mark this one as populated, and then we have the 100 microfarads. These will have to stay in big, because they are even thicker here. Yeah, expensive buggers in ceramic. At least. Oh, they are heavy too. 2, 1, 2, 1, 2. There we go. These have the expected aspect ratio in vertical. So yeah, let's look. There. Both directions. Fat. Chunky chunks. There we go. Yeah, it's a good tool. Having all the necessary filters and parts, you can't get them that cheap. It's like no free lunch for good tools, unfortunately. Also, people put a lot of effort into them, so it's one would wish things were sometimes cheaper. But on the other hand, when you make stuff, you start realizing, yeah, there is a reason why it costs so much, and why it should cost so much. Yeah. But yeah. Become a patron, then I can afford it. Haha. There you go. Okay, so the 100 nano, or 100 microfarads, 100 mics. Next, we do the 1 kilo ohm, 4 of them. Oh, this doesn't even have a, that's a weird package. It doesn't have a ziplock on this. DG key, what are you doing? I think these are pre-packed. They just have them in stock in this format. Where are you? There. Yeah, so these, I think these are pre-packed bags of 100 that they just send out. How many? There are 4 per board. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I wanted 1%ers on this. I wanted something more accurate. There we go. One, 2, 3, and 4. There we go. Yeah, for audio frequencies, yes. It's like, yeah, but so I'm saying I didn't give enough enough context here. It's not just audio is just one of the reasons why I would want a spectrum analyzer, but what I also want to be able to do is actual RF ham radio related stuff in the future. So yeah, I could probably put something together with like a sound card or something weird like this, but if I'm getting a tool, I probably should invest into a proper tool that will carry me over for later. And of course, I lost already a part. Great, well done. Just likes to sometimes snip out of the tweezers. And I don't even have a carpet, and I still lose parts. There we go, and one, two more. We're getting there. I think it is KJ7ABV. It's on my Twitter. I do so little ham recently. It's like I need a proper station. It's in my Twitter profile if you want to look it up. I should do more ham stuff. That's the problem. I need finally a station. The problem I have is I have this crappy Baofeng radios, and I use them, but I can reach only one repeater in Eugene, where I am. And it is just really hard to actually use them for any real fun. So I need an antenna on my roof. At least I can put an antenna on my roof. That's the plus, and get a proper station up and running. But I need to invest that money for it, so it's not happening at the moment. Okay, so let's do the buffer inverters. One, two, three, four, five, six. Wah! There we go. 2, 3, 4, 5, 6. Good. So I think they go this way. Is that visible? No, it's not visible. There we go. So there is, I think, a dot. I'm not sure it is visible here, but there is a dot there. There we go. There we go, 1. Don't snip it. 2. So many markings on these parts. That's crazy. I'm not sure this is visible. I should show you. This is really weird. See how many markings this thing has? Yeah. It's like multiple dots, multiple bars. It's like, why are you so confusing? I assume this dot here on the corner is meant for marking the pin 1. So, well, we'll see, I guess. Ugh. Focus is off. There we go. There. 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 Cool. All right, and one more. Almost there. Almost there. Come on, rotate. Oh. Okay, cool. And we just need the level shifters now. Okay. Let's mark these as done. Now we can do the level shifters. Level shifters I have here. Yeah, it's probably they try to mark exactly what it is. These are interesting parts because they contain, I think it's from a series that contains different logic elements in one package. And this one contains a buffer and an inverter in one package instead of just two inverters or two buffers. And so this is a slightly odd part. But that's what we are using. And then we need a bunch of these. Come on, guys, come out. 1, 2, 3, 4, 5, 6. 7, 8. One more, 9. There we go. Let's hope we can get this done here. Good. Where is the, oh god, where's the 0 mark? There. Is that visible? Yeah, I think it is visible. I need to go for lunch. My blood sugar is dropping and I get jittery. Okay, 1. 2. Oh, come on. Oh, one happy teddy bear. Welcome. It is late for you, especially. Did you have a good day? What are you up to? There we go. Number 2. There we go. 2. There we go. Cool. And last one. We can finally reflow this guy. Man, we went on so many tangents that it took us... Whew, we are way past our allocated time. So yeah, I think... So the problem I have, I'm not sure I will be able to stream on Thursday again. Probably this will... I will finish assembling what I need to send out so that it is on the way to Sylvain, because it takes a while to get to Europe. But I will continue assembling and testing of these on the next stream, but it might take until next week, unfortunately. So we will... Anyway, so let me put it in the oven. Oh, very cool. Having fun with coding. That's good news. I'm glad to hear that. All right, so give me a second. I'll be right back. I will leave you with maybe the desktop view here, so you can look at this board. So what we still have to solder in is the Pmod connector, the gamepad connector, and the audio connector, as well as the 5-volt power supply aux. So we need to do that, but otherwise we have all the parts placed. So yeah, I'll be right back. Okie dokes, I'm back. So the boards are now in the oven and they should be ready in a few minutes. Let's see, it's 35, so it's probably 1440 should be done. So now let's investigate what we need to do else. So we could put together one of these pods. I need to put all of them together essentially, but yeah, what we need is the connectors. Maybe let's put this one together. I can solder on the capacitor. So I added some decoupling capacitors on this. Oh, that looks interesting under the microscope. It's a different color. So I did add decoupling capacitors just in case on these. So it's like I am putting them everywhere. Just to stabilize the supply for the gamepads. So this is the Molex SL, I think, connector standard. So we need to put these together. Yeah, actually, so because all these things seem to be mostly straightforward, I might be able to actually do this stream on Thursday if this doesn't require too much preparation and post-processing. So maybe we can do that the date after tomorrow. But yeah, for now, let's should I just solder them together and not worry about the capacitors for now? I probably just should do that to get something for test purposes. So let's get the connectors. Well, let's put one of each together. Then we should be ready. 1, 2. So they connect with ribbon cables. And we will get the ribbon cable. So one interesting thing, that's something people don't know very often. The shrouded connectors have a pin 1 marker. See the triangle? This is molded into the shroud. So if you have that, then you also usually have a square pad, which is the pin 1. And on KiCad footprints, you also have this double corner. So this is the pin 1 indicator. So this goes this way on the board like that. So yeah, just letting you know in case you didn't. We can do this. Let's take the. Whoa! Now I probably keep making holes in my LED illuminator. Yeah, I smell it even. I touched it. Great. Yeah, so I do use the microscope even for boring stuff like this, in theory. So the important thing is hold the soldering iron to the joint where you want it. This will take a while to heat up in this case especially. Did I not switch it on? I think it is switched on. It just takes forever. It's quite a mess. There we go. There we go. Let it cool down. Now we can, will this work? Maybe as a support. Either this or the alternative would be to use stick vise, which I love dearly. So these are stick vise. They are really good PCB. Yeah, they are the best. So I can just plug it in here like this and stabilize. The problem is, of course, that I would have to press it in the back, but for the pin 1, it's usually pretty easy. We can adjust. So I use JBC irons. It usually is very fast. It's sometimes I have like heat connection issues. So you see this is just reflowing immediately. It's not a problem. I think I have it set a little bit high at the moment. Yeah, it was 370 because I was lazy and I was doing something very coarse. But yeah, spendy? No, JBCs are worth the money. That's what I would say. This is the general conversation about tools. It's like tools cost what they cost for a reason. It's like you can get a Hako these days for cheaper. I heard good stories about this. I use some. They are okay, and it's still not a JBC. Especially the collection of tips you have. It's like now the people are making open source re-implementations of the station itself, so you can use the tips and handles. But this is where the most of the money goes into at the end. At the end, the station is a one-time investment. But where the actual money goes into are the blades, okay, or the razor blades, right? So the tips. And the nice thing about the JBC tips, they actually last a very long time because of all the protections the station itself it has. So if you put it in the station, it automatically detects that you put it in the station. It switches off the tip. It goes into like a low power mode, so it is not as hot. And then after a little bit, it completely switches off into hibernate. So you don't have to remember to switch off the iron. So it automatically manages your tips, which is really nice. And so there are, and this is this one is really old. It's like I got it like on eBay as a used one, and so you don't need to buy the new one. And it's like at the end, even a new station, if you do this more than just for funsies and you are completely broke, then it's, what is it? It's $300, I think, for the station itself, and it comes with tips and whatnot. So, if you ask me, this is not a bad investment. It's like this is your tool of trade. Just treat yourself. On the other hand, the alternative is going with Metcal or equivalents, but yeah. So. There, in my opinion, JBC or Metcal. These are the two choices you have. Yeah, that's a reasonable price in my opinion for a good iron. They do heat up really quickly too. It's they're a pleasure actually to use. So let's do this one. One has to go first, like that. I have to do it on the desk first. There we go. I thought I filed this one down. Weird. But it's not filed down. All right, so can add the decoupling capacitors later. They are not that relevant in this case. And see, this is like all connected to ground. It still does a very good job. So quite chunky connections here, even though I have the thermal reliefs there. There we go. What the? Oh, did I just? The LEDs were like blinking like crazy. Oh, I guess I have like a short here. That's not good. I have the LED string here in the back that is like blinking, and it just went crazy. It's like you see it in the corner there. There. And I had a free flying wire, and it just connected, and it was like blink, blink, very bright. It startled me. Okay, so this will be now interesting. We have these retained connectors. Let's see. So are these. Come on. Can it focus? Maybe I should just show you on the desk here. Well, this is the connector. It's a through hole. And it has nice clips. So now, the satisfying click. Let's see. Will it work? Ho ho ho, that's nice. Nicely retained. And click, haha. That's lovely. Thanks, Smolix, for some satisfactory click. Ah, yes. Very nice. So yeah, these have connectors that go on the wire that also have clips that you can press on and then retain it in here, which is very nice. So yeah, we will do this. Is that too high? No, it actually works. Very cool. All right, so let's solder these. Yeah, it's better than. Yeah, it's not. Is it aerospace? No, I don't think it is aerospace. But we did use them in UAV quite a lot. They were definitely our weapon of choice there, to have something reliable enough so that the airplanes didn't fall out of the sky on their own. It did help. It definitely did help. We used some not retained connectors once or twice. That was a bad idea. And bit us in the ass very quickly. And you had connectors that vibrate away. There we go. So yeah, you see the gamepads are connected with clock, latch, and data. So this is essentially a shift register that is in the gamepad. That's all it is. And the shift register is pretty old. It actually says switches between parallel and serial mode with that pin, with the latch pin, which is, I find a little bit funny that they call it this way instead of just latch. But yeah, essentially it is a bit different functionality where you can not shift when it is in parallel mode, which would be interesting if one could. There we go. Yeah. So you see, this is like, this thing doesn't really have much thermal mass, and you can still heat up the ground plane fairly quickly to connect connections to a big plane flood. Very nice. So that's it. That's the first pod fully assembled. Let's see. Ooh, that looks fancy. I like it. That's a very pretty board. The aesthetic, as you would say. Thank you, Oshpark, for being awesome and making beautiful boards. Ah, that's the backside. There we go. Very, very pretty. I wish they had 4-layer After Dark. I really wish they would. That would make me very happy. I need a few minutes alone. Yep. Let me leave you for a second. I'll be right back. Right, Jared? Okay, so now we can put these together. So these are SNES connectors that I got from AliExpress. So yeah. Yeah, the TS180 and TS100 are really nice soldering irons, really good for traveling. They are almost as good as the JBC standalone iron. They are very impressive. I use them as it is my go-to for a travel soldering iron. It's still not as good as the JBC, but they are impressively good. Okay, let's see how that works out. These are chunky as hell. It's not a big tip that I'm using here. I should pull out the extractor. I'm giving you kids bad example. Oh, let's pull it out here. Oh, I should put the microscope back up. There we go. But yeah, we have proper extractor here now. Let's switch it on. Should get a bigger tip, I guess. Still working. Flowing slowly. I have to get those black SNES connectors that I pointed out in the last stream. All right. Are you talking about Otter Iron? Yeah, Otter Iron is really sweet. I met him at the Congress. Jan Henrik. He even offered me one of his prototype boards, but I was like, I will probably not come around to put it together, so I turned him down. He gave it to a few people, but I've seen it since, and it's really cool. There's also Otter Iron Pro, which is essentially the electronics to drive JBC irons, the hands and tips. Greg DeVille got one of those boards, so I'm looking forward to his review of that. That will be great. I hope he makes it into a nice product for the nerdy open hardware people. There we go. Almost here. Only a few more joints and we are done with that too. There we go. That's the last one. There we go. Perfect. Let's see. Solder poking technique? Yeah, I don't know. I'm just heating up the two surfaces that I need to solder with the iron, and then I'm adding solder until satisfactory filling is completed, because it takes it time to soak into the gap. That's what I'm doing. But I'm sure there are many successful ways of doing it. There we go. Another one. Pretty, pretty, pretty. That looks great. Yeah, After Dark is pretty. Okay, so now we have the two pods. We need the ribbon cable for that eventually, but now let me get the board out of the oven. I'm sure it is long done, so I'll be right back. And we are back. Let's see. Yep, that worked. Very nice. Okay, so now let's add the connectors. So let's review this under the microscope. So that looks fine. This looks good. The DFNs also reflowed nicely. So these are DFN parts. Looking good. No shorts, no nothing. These seem to be working fine. This is not a bad package. This is like, what is it? SOT363. So it seems to be a good package. We will be probably using these on Glasgow instead of the SOT333s. So I like that. These seem to be much more robust. They probably will not get so many bridges as the SOT333 usually get. This is the second. This looks good. And we have the one that had this. Yeah, this one is slightly dry, but it's still connected. The one that we had the screwed up solder paste. Can we get that in focus? Still has a little bit of a fillet there. Did connect. It's not great, but it still worked. Yeah, it's just this minute, like 0.1 millimeter more between them that makes a big difference. So yeah, this I'm very happy with this. So I'm happy that we are switching those over on Glasgow. That will make reliability much less of a headache. I probably should do the same on the Blackmagic probe and get rid of the SOT333s wherever I can, because they seem to be a fairly painful footprint. Okay, so that's looking good. So let's just put one of them together. Then we will wrap up the stream. So what do we need? We need a Pmod connector, a straight connector. We need the bucket here. So let's start with the Pmod connector. Do they make DFN footprint ones for the buffers on the Glasgow? That's a very good question. I think they might. The problem was that I wanted some. Yeah. Can we reset public? Oh yeah. I did reflow BGAs with it. That's not a problem. Reset public. So to answer your question, yeah, BGAs are not a problem. That's why I bought the oven in the first place. I needed to reflow some WCLSPs for STM32s for an autopilot I make. Like in the slideshow you see it, it's the Lisa S autopilot. And it has a WCLSP STM32 0.5 millimeter pitch BGA. But yeah, you can do that. Yeah, you can. I used mine without the mods for a while. The biggest, this was a pretty big mistake though, because I didn't even know about the masking tape inside back then. So the biggest mistake was not removing that immediately after getting it. It was so stinky. It was so bad. It was just cancer oozing out of this thing. It was just bad. But yeah, it took many, many hundreds of cycles to get rid of the stench. But yeah, I eventually did remove that. So this is the minimum you have to do, is remove that masking tape and replace it with Kapton. So yeah, otherwise, yeah, you can use it. You might burn boards or get bad reflow characteristics without the modification, because the temperature sensing and tracking is not great with the stock firmware, but it will work. It's pretty interesting to actually not have modified it and then modify it and realize how much of an improvement that is. As with everything, you appreciate it more when you see how bad it was before. There we go. Should switch this back on. Caramelization on this is good. I like that term. Yeah. They just don't track very well. The circuit on the board that is used for the thermocouples is very inaccurate because it doesn't have a cold junction compensation. You can either add the cold junction compensation to the board with the firmware change, or you can just use a proper thermocouple interface chips that are one wire that you can hook up. This is definitely the best choice because it does it internally. Okay, so that's one. Then we need the straight connector for the 5 volts supply that we will want to use eventually. So let's put that on while we are at it. This is supply for the gamepads. But this board will work with 3.3 volts, so there's this jumper that you can use with 3.3 volts or 5 volts, so I'm adding the auxiliary 5 volts. Like this. This is very specific mod on the icebreaker for the Pmod to have that additional pin header on the side here. There we go. That should do it. Yep. Whoop, come on. There. There, good. Now we need another bucket. That should be correct, yeah? No, it's not correct. This way. Pin 1 is this way. So I have them oriented like this, the 2 connectors. This is the pod, and this is the Pmod. Pod, Pmod, so the wire just goes straight from one to the other. So we don't need to worry about this too much. There we go. Nice. Oh, I should have done the audio first. Oh well. You want to start with the shortest ones first, because then you can just put it on the mat and solder them in without them just falling out. So yeah, that should have done that. Let's hope I can just hold it with my finger though. There we go. So yeah, now just the audio connector, if I can find it. And we are done for today. Right, yeah, we are. Oh, it's actually like almost sticks in here. This is the beautiful. Bob Miller, K-Bob, he found this connector on DigiKey. It's a lovely connector. I like the... Let me finish soldering it. I like how transparent it is. I like the transparency a lot. Can I just shim it like this? Nope, I can't. So let's add solder here, just to retain it a little bit. Then we can press against this. There we go. Then I can solder the rest. Still a very odd footprint with the location of these pins being in the most random places possible. That's the annoying part about this. Come on. There we go. There we go, 2. And there we go, 3. We're almost done. Very good, very nice. Okay, cool. Now let me show you the audio adapter I got. So I got this USB DG Now, whatever, USB audio capture thing, and it has the RCA connectors for left and right, and it has the 3mm jack. And then when you look here, this is very nice. Yeah, you see the action and all the connectors being. You see the connector on the end. It disconnects here, and the other one disconnects on the top. So these are the switches inside the connector, which is very nice to see. So this connector is actually switchcraft connector. So let me show you this one. Is that visible even? So this is the part. It's a switchcraft 35 Rapsi. So let me just look it up. I will give you the DigiKey link to this. This one. And then share. I should get kickbacks from DigiKey. Here you go. Whew. This is how you break things, kids. Okay, so what's going on with these headphones? They're very different sounding left and right plug for some reason. Anyways, TRS, yeah, not enough pins for you. Yeah. So but this is pretty much it for today. So this goes into the icebreaker and provides. Where's the icebreaker? There we go. So this is the icebreaker. This goes into the icebreaker. This is the Pmod. So actually it is meant to go into the head connector of the icebreaker, because this one will be used for HDMI output or something. But for now I can test it with just one of the side ones. And these pods will be connected with a ribbon cable. I got the connectors, I just have to crimp them to connect to the pods. These pods actually can be used in parallel, so you can connect to player 1 over one pod and then player 2 on the second pod. And when we have the third pod for the NES connectors, which would be these, then we can have mix and match different different gamepads. Not sure why, but I have, I think, two SNES ones that will have these connectors and two that will have the original connectors. So I think I will actually use these two pods. So don't connect, of course, like the same game into the same game port, two different gamepads. That will probably not work right. But otherwise, this is an option to have multiple connectors on the system for different gamepads. So yeah, that's pretty much it for today. I'm looking forward to try out also the audio circuitry. That will be very interesting. Serge Vala, thank you for the follow. Welcome to the stream. And one, thank you for the follow too. And Jackbacks, thank you for the follow. Geeklord, I think I said hello already, but hello. Yeah, I was just checking what we have here. Anyways, so I started on the gateware for this. I wanted it to be ready for today, but I did not manage to do that. Also, we obviously ran out of time. So it's not all lost. But yeah, I did start on a state machine to read out the gamepads, at least. I hope I will get something a little bit more useful together. As I said before, I probably... Wonsky, welcome. How are you doing? Yeah, so we will work on this. As I said before, I probably will not be able to stream on Thursday this week because there's just too much stuff to be done that I need to catch up on. But definitely next Tuesday again. If this changes, I will, of course, let you all know. And in the meantime, I will work a little bit more on the gateware stuff because you don't need to watch me fumble through this. It's like I will definitely keep some of the content of developing this for the stream. But if we do everything like that on stream, this project will take years, probably. So yeah. Yeah, we are almost done here. It ran a little bit longer than I expected. But yeah, if I have something ready for the day after tomorrow to just show off really quick regarding this Pmod, we might make just a very short thing of half an hour Q&A and show off, just like we did in the early part of today. But otherwise, yeah, again, as per usual, I would like to thank everyone who is supporting these streams and making them possible, because without those supporters, these streams wouldn't be a thing. So I really appreciate everyone who is not only buying stuff from 1-Bit Squared, but also supporting me with subscriptions on Twitch. I really appreciate that, as well as the Patreons that are so generous to donate money to the stream. You can check it out if you want to join in and help out also. I really appreciate that. It's very helpful. Yeah, and as always, I would like to give some shout outs. One thing I have to do before I do that, though, is yeah, anyway, so for this week, I would like to give a shout out to a few Patreons that are wonderful and very helpful, and they're in the shout out tier. So thank you very much, Jamin. Thank you, Brennan Ashton, Drew Fustini, Edward Borden, Go Jimmy Pie, Jeff Wang, Jordi Parky Rodriguez, Kelly, Miha Benovets, Sid Price, and Tom Keddy. Thank you so much, all of you, and everyone else who is watching. It's like I love sharing this stuff, and if don't worry if you can't afford supporting this, that's fine. I'm glad you are here. The people being here and watching this are making it also very much worth it. And so I'm really appreciative of everyone who is taking their time and hanging out and asking questions in chat and being part of this community. Check out the Discord chat that is being posted there. Join in, take a look. Join in conversations, learn something, share your knowledge, build something interesting, learn about digital logic. It's a very interesting, brave new world that not everyone has access to so far, and I'm hoping to make it a little bit more affordable and a little bit more accessible and explain to everyone I can how to use it. So if you are having trouble setting up the open source toolchain, just ask in the Discord chat, and I'm sure there will be me and others that will be happy to help out. Yeah, so as per usual, I will say goodbye and see you either on Thursday or Tuesday next week. And as always, if you have been, thank you for watching. Bye!